Welcome back to the Query Manager video tutorials. Let's now focus on a handful of options that can make your life much easier if you run a lot of queries. And at some point of your project you will. Don't just enter data in your database to leave it there. Sooner or later you will want to see what you have entered and what your data will tell you. Anyway, I call this video shortcuts, so the video itself will be short. I want to highlight the following four options: subqueries, automatic expansion and contraction of nodes down one level, automatic expansion of nodes down any level to simplex of specific value types, and cloning. Okay, let's get started. Let's open the Query Manager by pressing F6, and let's go to the File tab. Do you see the three images on the right hand side of the top bar here? Let's become familiar with what they mean and what they can do for you, since they can be great time-saving tools. To see how they work, let's open the Save Network Query. As you can see, the object actor appears under both participant S and participant O, basically as both subject and object. Unfortunately, under the actor as subject is a collective actor, and under the actor as object is an individual. But suppose that both actors were exactly the same. The more objects you have in a query that are repeated, the more complex these queries are in terms of nested children, and the more annoying it is to have to repeat the same steps to construct a query. Subqueries are a nice way to avoid this. So let's first build a new actor query that we could then substitute to one of the two actor nodes in the network query. So let's click on the Build Query tab, click on this button to create a new query. We select the complex actor, then individual, and name of individual actor. And now we can save the query as actor. Alright, now let's reopen the network query, click on participant O, and delete actor by using this button here. That will delete all the children of the selected node. Now we can go to the File tab, select the actor query, and click on the tree image while we have selected participant O in the tree. Notice how a subquery is turned to green automatically when selected. What this does is to display in output all the subqueries shown object. If you do not want to see all the subqueries objects, just click on the subquery image to deselect it, and then select any of the children that you want to see from the earliest children other objects list box. In our case, we only have one terminal object, so no need to deselect the subquery and import the selected children. I have saved this query as network new here. Now we can try to run this query, and voila! Much easier to construct complex query where certain objects are repeated several times. In fact, had the original network query contained the same simplex name of individual actor under actor and under both participant S and participant O, we could have used the actor subquery under both. Let's try that. Now let's close the query results form, and let's delete actor under participant S and add the subquery actor from the File tab. We select the subquery, select the object, and then click on the tree image here. And here you go, much easier. Indeed, the subquery tool would have been very useful when we built the query triplet test in our first tutorial on the QM, since the actors under both participant S and participant O were individuals. We can take a look at the query again. And here it is. We can delete the nodes actor, both of them, and then select the actor query here, and then click on the tree after selecting the object where we want to add the query to. Let's now turn to two other time-saving tools found under the Build Query tab. Now let's delete the participant O object in our network query, so this actor object here. And now click on the plus button right there. Now the code behind the button will expand the participant O to include all its simplex objects, all the way down to the terminal objects, and all its complex objects, stopping the expansion at the first level of depth. In other words, the expansion stops at the complex children of the selected object, and not to the children of children, children of children of children, and so on. The X button here will perform the inverse operation, removing all the children of the selected object, while the delete button next to it will remove not only all the children of an object, but the object itself. You can achieve the same result, by the way, by hitting the delete button on your keyboard. Now, let's take a look at what the set of options grouped under the Add Simplex Below Complex section here do. Basically, they allow you to expand a complex objects to all its children, both complex and simplex, all the way down to terminal objects where these terminals contain specific value types, numbers, strings, dates, and even specific values, at any depth you choose. That's right. Now first, let's delete participant O, and let's add a new object. Okay, now we can select under this section the simplex type string, and type the word Negro to use the language used in the newspaper articles of this research. Note the wildcards are allowed when you use the like operator in SQL. So by writing the string this way, I will get all the values that begin with the same four letters of the word Negro, and then I will include also the plurals and all the variations of this word. And then you can choose the depth at which you want to retrieve your data. Or you can leave the depth equal to 5. So this value represents the default value for how many generations of children the search will consider. So children, children of children, children of children of children, and so on. Let's hit add and see what happens. Okay, we have added automatically a large number of objects. We could make it even larger by just using a star rather than typing a string here in this field. Let's look now at one last time-saving shortcut. We find it under the Select and Filter tab, here, and it is the Clone button on the top right-hand side of the form. Suppose that you have a large number of terminals that all have the same kind of filter values, so conditions. You can set up one terminal with filters and then click on the Clone button to turn it on, and with the terminal that you want to clone selected, you click on all the other ones that you want to clone, and magically all the properties of the first terminal gets transferred to all the other ones. Let's give it a go. Let's go back to our favorite query, the network query. So let's remove the children of actor under the participant S, and let's expand the object using the Add Simplex Below Complex set of tools. We select the simplex type, we set up the filter and the depth, and then click on Add. And here we go. Now we can try to add a filter to any of those newly added simplex values. From the Select and Filter tab, we select the operator, like for example, the value, that can be the same that we used before, and then we can click on Add Filter. Notice how the terminal has now turned half green and half red. Green means selected for showing an output, and red means it has conditions. So here's the result. And now if we select this object, then turn cloning on, and if we click on any other simplex objects in the tree, we can copy the properties that we have in this node to the nodes that we click on. So here, here, and so on. As you can see, they all take the same properties of the original object. Another little saving device if you have complex properties attached to a terminal object repeated several times under different parents in a query. And we are done with the Query Manager tricks to save time.